In this video, we're going to use the U-substitution and the Arctan formula to evaluate these two integrals here. Got a trig integral here and one with a rational integrand here. So, of course, the standard U-substitution you should be familiar with. And when I say Arctan formula, we're talking about this one here, number 14. If you have an integral of the form du over a squared plus u squared, the value of that integral is 1 over a. A squared is a constant here, and that multiplies the arctan, whatever u is, over a, plus the constant of integration. So the first one involves the u substitution. And the second one actually will also involve a u substitution, and that's to get it in the form where we can use the arctan formula. So here I know that the derivative of tangent is secant squared. So this one's pretty straightforward. We just let u equal to tangent of x. Then du would be the derivative of tangent. Give us secant squared of x dx. And now we can transform the integral into one involving u. So tangent is u. So tangent to the fifth, then I can replace it by u to the fifth. And the secant squared dx, that's your du. And we integrate this with respect to u, get u to the 6, add 1 to the 5, divide by 6. That's your constant, plus a constant of integration. C. Then we just go back to the original variable, replace the u by tangent. So we get tangent to the 6 of x over 6, plus the constant of integration. Tangent to the 6 of x again, over 6, plus the constant of integration. So that's the answer for the first one. Now this is the one that's going to involve the formula for arctan. So we got to put it in that form. So the formula was, the integral has to be the form du over u squared plus a squared. Or it could be the other way around, a squared plus u squared. That's supposed to be, or that's supposed to have a value then of 1 over a. This will be arctan of u over a plus a constant of integration. So think of this as the square root of 3. Let's write this as the square root of 3 x quantity squared. Now you can do it without doing this, just to make it clearer so you can see what we're doing with the formula here. I'll replace the 3x squared by the square root of 3x squared, and then I'll let u equal to the square root of 3x, then du would equal to the square root of 3 dx. And then we divide by the square root of 3 here. These cancel out. Push the square root of 3 over here. So this will come in. Make the substitution here. So the dx here is replaced by du over the square root of 3. I'll put the radical over here, 1 over the square root of 3 outside the integral. And then we've got the 4. You can write that as 2 squared. So it looks like the formula over here. That's your a there. And then for this one here, the square root of 3x squared, replace the square root of 3x by u. Got this. So let's go over here then, and this is going to be arctan. Let's go directly to the formula. It's going to be arctan of u over a. So in our case, the u is the square root of 3. So this will be u will be the square root of 3x over the a. In our case, we have a squared, so a is 2. So this will be over 2 here. And then we have the coefficient here would be 1 over a. A is 2. So I'm going to put a 2 here. 1 over 3 square root of 2. So let's rationalize that. There's a 2 here, and multiply by the square root of 3. So it's going to give me the square root of 3 up here then. Then the 2 here. And then this is going to be 3, so it'll be a 6 here. So again, the 1 over the square root of 3 is there, and then of course on the formula I have 1 over a, that's 1 over 2 in our case, and multiplying 2 and 2 here, rationalizing square root of 3 here, get square root of 3 over 6, and then it's plus the constant of integration here. That's the final answer for this one. Square root of 3 over 6 multiplied by arctangent of the square root of 3 over square root of 3x over 2 plus the constant. Thanks for watching. We'll see you next time.